Hello everybody. So today we are going to be talking about solving just different types of equations. So hopefully you guys remember back to our second chapter where we talked about transformations, how to graph things quickly. We're going to be relying on some of that information throughout this chapter. So let's take a look at this first problem here. So we were able to find all those special points, in chapter 2, like the growth pattern of how to graph a quadratic or a square root, a circle. We talked about a lot of different kinds. So looking at this equation here, we got y equals x plus 3 squared minus 5. We can tell real quickly that is the correct graph because we went back 3 and down 5 for our vertex, and we go over 1 up 1, over 2 up 4, over 3 up 9. We use our growth pattern to graph it. So the first question there is, how many solutions does it have? So what do you guys think? How many solutions would this thing have? It's kind of hard with not being in class to answer this. So there are 2. Hopefully you guys said that. And it's where it crosses the x-axis. So we can see they don't cross at nice, neat points, but we do have 2 solutions because we can see it cross the x-axis twice. So you might hear those called solutions, roots, zeros. They use a lot of different terms for them, but we're just trying to find where it crosses the x-axis. So this is use the graph to solve the equation for x plus 3 squared minus 5 equals 4. Well, the only difference between this one and the previous one is that they plugged in 4 for y. So what we would want to do here is we want to make a line at 4. So let's draw a horizontal line at 4, right there. And we're going to look and see where it intersects. So hopefully when you look at this, you're like, oh yeah, I can tell it intersects at 0. And what is that? -6. So 0 and -6. And again, there's the 0 intersection, the y value is 0 and -6. I'm sorry, the x value is 0 and the other x value is -6 where it crosses. So that would be our 2 solutions. So we didn't have to spend. So 3 strategies that we could use to solve these problems. We could look at it as rewriting, looking inside, or undoing. So I think we've all done this before in our Algebra 1 and geometry classes. So these strategies should be very helpful to us throughout the rest of this course because we will see some uglier equations as we get further and further in Algebra 2. So we got Ernie decide to multiply both sides by 20 so that his equation becomes 5 times x minus 5 plus 8 equals 18. So what strategy did Ernie use? He used rewriting, right? So he just multiplied to get rid of the fractions to make it easier to solve. So Elle took Ernie's equation and decided to subtract 8 from both sides. So what strategy did she use? Well, she was undoing, right? She was getting rid of that plus 8 by adding or subtracting 8. Hopefully we know all this already. So Eric looked at Elle's equation and said, I can tell that x minus 5 must equal 2 because 5 times 2 is 10. Therefore, x must be 7. So what strategy did he use? So he was looking inside the original equation, right? Well, we can still see it right here. He was saying, what does this have to be to get 10? So he was looking inside. So how many solutions does this function have? How can you use the graph on your graphing calculator to check the solution? So I cut a little bit of them off. And where would you look on the graph? So what you'd want to do here is type it in a graphing calculator or Desmos and then look at the graph and to figure this out. So all right, so here are some different problems, and what I'm going to ask you guys to do is just to pause it here and attempt to solve for x on as many of these as you possibly can. And then we'll talk about this, but just go ahead and pause it and try these. All right, so our first example there, if we're going to solve for an absolute value, we need to get the absolute value by itself. So step 1, divide everything by 4. And then we are left with this. Now that the absolute value is by itself, we can break it apart into our 2 equations. I don't know, you might have been taught a different way, put a plus and minus in front of the 2, whatever, it's fine. So now we just got to solve both of these equations for x. So we're going to start off by adding 2 to both sides, and then we're going to divide everything by 8. and that would give us x equals 0 and x equals 1/2. So absolute value, get it by itself, split it apart into its two equations, and then solve for the variable. All right, so the next one, the square root. So we've got to undo everything and get rid of that square root. So we're going to start by subtracting 9 from both sides. And now we got that 3 out front. Since the 3 is being multiplied, we got to divide everything by 3. And our next step would be to get rid of the square root since we finally have it by itself. So we square both sides. So we have 4x minus 8 equals 4, because 2 squared is 4. We're going to add 8 to both sides. And we get 4x equals 12, and then we're going to divide both sides by 4, and we get x equals 3. All right, so this is solving a quadratic. So we want to get the square term by itself. So we're going to add 2 to both sides. Oops. And now we can take the square root of both sides. So, well, at this point, we're going to run into an issue here. Now this is where I'm going to stop. Remember, we cannot take the square root of a negative number. So this is telling us that this graph doesn't cross the x-axis at all. So we would just say, for this situation right now, again, we could solve for its complex solutions, but we haven't talked about that yet. So we would say that this has no real solution. Okay? All right, so with this one, we're going to have to multiply everything out and get it equal to 0. So we can use the FOIL or the box method. So if you did FOIL, first times first, outer, inner, last, combine like terms. So now we want to add the 12y and the 18 to both sides to get everything to one side. And now you're looking at it like, great, now you have to factor it. So you're exactly right. We could use factoring, we can use quadratic formula, but I want to go factoring. So we're looking for two numbers that multiply together to give us negative 24 and add up to be negative 5, right? So I'm going to skip all the work of the factoring, but because we've talked about that. So we factor that. So what two numbers multiply together? Figure it out. And then you use your box method, and you should end up with this. 2y minus 3 equals y plus 4. Then we can set both of those equal to 0 and solve them. And we would get y equals 3/2 and y equals negative 4. That would be our two solutions. All right, so this one is kind of a nasty problem, but all we need to do here is rationalize our denominator. So if we look at this and say, what is our least common denominator in this situation? Hopefully we see that it's a 3x. So we're going to multiply everything by 3x. So I multiply the first 5 over x by 3x, I get 15. I multiply 1 by 1 over 3x times 3x, I get positive 1. Then I multiply 4x times 3x, and I get 4x squared. So now we're just going to combine like terms. And looks like here we need to divide everything by 4. We want to get that x squared by itself. So now we got 4 equals x squared. So we take the square root, and we end up with positive and negative 2. All right. And we want to check those, plug positive 2 and negative 2 back in and make sure they work. All right, so absolute value is equal to negative 6. So we could start working this out, or hopefully you guys will tell me that absolute value always creates a positive value, so there would be no solution here. There's nothing to work out. All right, that was a little blurry. We're just going to skip over that one. Okay, so with this one, this looks like a circle. No, we don't have a square on it, and there's no other y. So what we need to do here is just multiply this all out, combine like terms. So I'm going to do x plus 2 times x plus 2. I distribute my 4 to the x and the plus 2. So now I'm going to do FOIL here. First, outer, inner, last. And that's where I got this x squared plus 4x plus 4. Notice I just combined the 8 and the negative 5 to make a positive 3. So now again, combine like terms gives us x squared plus 8x plus 7. Now we could try and see if this will factor. It might be the easiest route, and it does. Two numbers that multiply together give us 7, but add up to be 8 are 7 and 1. And then the two values that make these 0 would be x is negative 1 and x is negative 7.